Alright, I'm going to be making a double-sided circuit board with a 3018 Pro, which there are a lot of variations of these machines out there, and this video will pretty much apply to all of them. Like Saint Smart makes one, etc., and they call them sometimes something different, but any machine that basically looks like this is essentially a 3018, and if it uses like Candle, which is the included software, that's what I'm going to be using for CNC milling. I'm also going to be using Flatcam, which this is a pretty recent version, but it's actually about a year old. This is July of 2021, by the way. And I'm going to be, my circuit board program is KiCad. So all this stuff is free software. This won't be so much involved in KiCad because the board is pretty much already designed. I did just have to shrink it in length to fit on my little board here because it's only like a little over 6 inch by 6 inch. So, and you can see I've already actually routed one circuit board out of it, which is actually this board, and it's actually quite impressive what kind of resolution this thing has. Now this is a little webcam I'm using here, so it's not the greatest, but it's the only way I can do this really kind of interactively without cutting it together, because I hate having to render films, render videos that I stitch together. So I'm going to try to do this as a single continuous shot. But yeah, this actually came out of this little area here, as you can see. So and that's the little solder tab, which I'll explain later. Now there's a couple of things that and this is going to be a lengthy video, I can't help it, so there's not much I can do to kind of trim it down. I like filling in the details because the devil's in the details. But I'll explain my setup. Firstly, this is just a particle board that I bought from Home Depot. It's like a 3/4 inch thick or something like that, just the cheapest stuff, nothing special about it. And you can see that I took a couple of bolts that actually came with this machine, and this machine came with a laser too for like $189 or something I bought off eBay. It's 5-watt laser, and it works pretty well too, surprisingly. You can see some laser experiments I did there, and this is white PVC, and it actually cut through it no problem. I would have thought white material would have reflected, but it would cut through white paper too. That laser is substantial. I mean, I would have thought that white color would have reflected all the light, but I was really shocked that it didn't. But this stuff right here, by the way, is expanded PVC, and I'll explain that in a second, what its role is. It's not going to play a role in this video, but boy, I highly advise you use this in the future, because I've used it in the past. I'm not using it here because I'm about to take this jig, because this table is like a 7 inch by 12 inch table, and you can actually use 100% of it for routing, which is really surprising because usually you don't get that on a lot of these machines. Usually you can't use the whole table footprint for machining, but here you can. So yeah, I'm going to cut a piece of this that's 7 by 12, and I'm going to actually, instead of the bolt being like this, I'm going to actually counter bore a hole about halfway through this material so that I stick the bolt in like this, and it'll go through a hole, okay, in the table itself. So underneath it I'll put a washer and a nut, and that'll hold it really really tight to that position. So, but yeah, I'll counter bore, I'll drill a hole bit the exact same size as whatever bolt I'm going to use. It'll probably be something skinnier than this. And then I'll counter bore a much larger hole that's big enough for the head, so the head, basically sinks down in it, so I don't have to worry about some machining operation running into it. Because, normally I'm not going to actually grout into this material, unlike what I'm going to do in this video, and have done so far. I've already made one board on this. Normally I don't do that. Normally I put this expanded PVC under it, and you can get this off Amazon, for about $10. You can get 3 12 inch by 9 inch sheets, I think it is. So it's not too bad, and the stuff lasts forever, but it's expanded PVC. And that means it's almost like foam, but it's real rigid. But it's real soft because it's expanded. So it's like expanded foam board. I mean, you could put like 100 pounds on this and it won't deform. but it's soft. So what that means is that you can, literally, you can see that on this piece right here, which is what I made a lot of double-sided boards off of. I've actually used this before. It was just an old piece for my K2 over there, which is the machine I usually make a lot of circuit boards. It's way more powerful than this, but it doesn't have like a height mapping feature in it like this does. So this is actually way more precise because of that. But at any rate, you can actually just keep peeling this off and putting new copper clad on here and use it over and over again until it's almost pulp. So I mean, I could probably honestly do at least 10 different panels on this before I would dispose of it. So it's great stuff, and you can often turn it over and use the other side when you're done. And anyway, to continue with my setup, another thing I use is this stuff, which is called and you can buy this off Amazon, I'm pretty sure, but I picked this up at a sign supply warehouse like 15 years ago. And it's called banner hem tape. Okay, they use it for signs. Just like this stuff, you can pick this expanded PVC up, which is 3 millimeters thick, in a 4x8 sheet for about $35 or so at a sign supply company if you have one in your city. So it's pretty inexpensive. They use it extensively in signage. So same with this. I used to be in the sign industry. That's why I know this stuff. But it's really good stuff, and I've used this for CNC work for years because you can just use it over and over again. And this tape is so good, and this is what's so awesome about it. If you want to use it for other things, like I stuck a light inside my freezer while it was running, and this stuff sticks just fine to a frozen surface. I mean, it works in freezing conditions. Most tape doesn't. Most tape craps out on you below freezing. But that's well below freezing, and that was like 20 below in there, and still works just fine, and that light's still mounted in there to this day. So, it's really excellent stuff. It's good for not just this, but a lot of stuff. And you can see it was used here, but it's very strong, but you can still remove it. This is tacked down with 4 stripes of this going from left to right across here. There's 4 of them. And that's more than enough to hold this in place. I don't have any mechanical fasteners at all. And by the way, too, when I make up, again, because I am going to make this platform here bigger and countersink it, and you only need 2 fasteners. If you follow what I'm talking about. If you didn't trust the bolts alone, you could use a couple of strips of this under it, and it would be fine. But there's really no need for it. The bolts alone will hold it, and you only need 2 of them. So you don't need to go stick 4 of them. That does no good whatsoever. I mean, I don't advise you waste it, and I don't advise you put any more holes in this machine tabletop than necessary in case you want to use it for something else. Because you can buy what they call T-slot bolts for this if you wanted to machine other things like do 3D sculpting or something, and you may want to get a 3D T-slot bolt set. Because you can probably find one on Amazon for this, and they're the proper thing to use. I've got one for some of my other CNC equipment, like that's a Shoreline type mill right over there. Anyway, I have some, it's got a T-slot table on it just like this. My K2 does too. So I mean, but you can use the right size just bolts from Home Depot. But some of those sets are actually a much better choice quite often. So, but it's up to you. It just depends on your budget. You can take like an oversized bolt if you want, and if you got a bench grinder, you can actually grind it flat on 2 sides and grind it just the right size so it'll actually fit in there like a T-slot. That's another option. I've tried, I've done that before. But like I said, you can see how I have this set up. But again, my first set was single-sided boards, and that's what I use this for. And again, it just had tapes, some of this tape at the bare corners of all 4 corners of this, and nothing in the middle. That was a big mistake, especially with all these damn holes I have in it. I have these holes in it because my K2, I had a vacuum hold-down table that I built. So this, used to hold my circuit boards down to a vacuum hold-down table, which is hooked to a vacuum cleaner, which worked well, but, these were... Anyway, it gets in the way here. I would have been better off putting tape all over it. That's why I had to put some pieces here, you know, because I used the crap out of it, because I don't like wasting copper clad. You know, I've got a ton of it, but I don't like wasting things. And that's why I like doing things in big panels. And I haven't seen anybody on the internet doing these out of panels, single-sided or double-sided, but I exclusively do it this way. And to give you a, you know, to save you the suspense, you know, again, this is the board I just did out of this. Let me move this thing out of the way here. If you're interested too, I lubricate my bearings with 3-in-1 oil. Some people say it's not a good idea, but it's worked for me on my K2 for years. So, you know, you just basically rub some over your, you know, your slides here and your screw, your lead screw, on top and bottom, you know, and just truck the, you know, the table back and forth and the head back and forth to fully lubricate it. But put as much as you can. Do it every now and then. You know, it doesn't hurt to wipe some of the debris off with a rag every now and then. But at any rate, yeah, this board, you know, I did out of this, and you know, what I did was, again, to save you the suspense, you know, the very first thing I did was really do a surface map on it, a height map. Okay, then I went in and drilled 2 reference holes. That's all you need, is 2 reference holes. And I used a, where'd that bit go? Damn it. Oh shit. Anyway, I used like a 42 mil drill bit. Fell off on the floor or something, piece of crap. But anyway, I used a 42 mil drill bit, just like these. You know, I had a bunch of these I bought a long time ago from like Drill Bit City or someplace. I don't know if they're still around, but they had good prices on things like that off of found them on I don't know, Yahoo or someplace. But at any rate, I just, you know, you just need like 2 holes in it for reference, right? And that hole right there is one of them. And then on the exact same place on the other side, you know, is one too. So basically, if you have a hole like that, and you know, that's how I drilled it, since I got it on the left and right side, what you got to do is you got to mirror your bottom layer left and right, so you flip it like this. Okay, and as long as you do that, those holes are going to be in the exact same spot if they're, you know, if they're on the geometry in the exact same place. Now, if you wanted to do it up and down, which is what we're going to do with this board, you would want to flip it over that way instead. But you'll see what I'm talking about. But it just depends on where you want to put your alignment holes. But they don't have to be, you know, in the exact center. You know, you can see that this is, you know, these holes are not in the exact center. They just have to be the same distance from the, you know, from like the top edge, for example. If they're both the same distance from the top edge, it'll flip and be in exactly the right place. And once you do, you know, once you're done, you know, routing your board, because the first thing you do is drill those 2 holes, okay, and then you do the route of the pattern, you know, with your V-score routers. And for this, I actually used this 45-degree tip right here. But on the board we're about to do, and this is a 3, you know, triangular cutter, what they call. Don't use those cheaper ones that are cut in half, because they break all the friggin' time. I mean, I got like a ton of them, but you know, they break all the time. Those, you know, those cheap ones. Like I said, I got a bunch of them sitting around here, but I don't know if any of them are unsheathed. Yeah, here we go. Yeah, these suckers right here, they really suck. You see how they're, you know, they're like cut in half. they're not triangular, the bit is, but it's like somebody just took a grinder and just literally cut the thing in half. So, in other words, you got kind of a conical point on one side, but it's just flat on the back side. So there's a single flat going across here. I wish this thing zoomed in better, but it's a webcam. But yeah, these suck. They break all the time. The tips break. But so far, these little triangular tips have worked great. But again, for this circuit board that I'm going to do, I'm probably going to use like a 30-degree tip, because the resolution on it is going to be... I'm going to be really surprised if I can pull this board off. I'm not sure. I've never tried it before. Because this is only the first double-sided board I've actually routed on a machine like this. I've never actually done this before. I've created tons of single-sided boards. I've done lots of double-sided boards using an etching process, back in the mid-90s. So, but I'd make literally thousands of boards that way, but not double-sided, but plenty of double-sided ones too. But at any rate, after you route your pattern, you pry this off. It'll have tape under it, probably, depending on where it falls, because again, I did 4 stripes of tape under it. But then what you do is you put, a couple of pieces of this banner hem tape, across it, right? Okay, and then you grab yourself, again, use the right drill bit size, a couple of thumbtacks. Okay, so you got your tape on the bottom of it, right? Damn it. You got your tape on the bottom of it, right? So if the tape would be on this side, right? Okay, so you take in those little holes, you stick your thumbtacks, and you want them to where they're tight, but they still slide in, right? So you stick them all the way in, and then you unpeel the backing off your tape, right? Okay, then you go in and stick it, look for those alignment holes. And voila, once you found them, alright, you press it down. Using these tacks to make sure it's in place. Press the tacks down and press the board down. Flatten the board so the tape sticks, and then you remove the tacks. The tape holds it. I don't have tape on it here, but the tape will hold it exactly where it needs to be. Now, before you do that, though, you see this little solder joint here? Solder yourself a little wire before you go through that process, and you probably should put it somewhere different than I did here, like over here or over here, where it's not going to be in the way of a future board that you may want to route, because that shit's hard to remove, and you don't really want your routers going through it. You can try with solder wick or whatever, but still, if you don't have that handy, my advice is just put it out of the way. But, you do that, so, because you'll have to height map it again once you flip it over. You'll have to run that whole, a whole height map on it so that you get everything level to the new board, because this is going to have a different height, so you're going to have to rerun it. And there's a couple of tricks to doing this, and one is that, unlike the mistake I made with this particular board, don't make the corner your zero reference on the exact corner of the board. Otherwise, chances are your height map is going to be really hard to make, because it's going to want to walk off the edges of this thing. Inset it by about 1 millimeter. It's 50 mil. About 50 mil both directions. That's what I use. That's enough to keep it confined, but don't make your pattern go to the edges. Again, you'll see that here. That's what I did here. This is the first time I'm trying this technique. But see, here's the board. I have plenty of relief on the tops and bottoms. Approximately a little over a millimeter. A millimeter is 39.4 mils. But this is 50 mil. So that's what I measure in mils. 1 mil is 1/1000th of an inch. But basically, here is where I'm putting my reference anchor. So, I made this little silk screen thing here, this little triangle, so that I can mount it to the corner of that. So you see, that's where my reference is on the corner of that little silk screen deal. But yeah, that should be your home. So that way, you know, it'll height map okay, and you won't try to walk off into the gutter. But definitely don't forget to solder that wire, otherwise, you know, your height map is not going to work out so well, you know, if you don't have that little solder joint there. Now, a little word about how I set my height mapping up, which I haven't seen anybody else do on the internet. You see, on every board, you know, on the top surface, you know, you solder a wire there, right? You only need to solder one on the top surface, you know, on your blank board. Okay, and that goes, you know, into the A pin. You know, you can see this on the internet. You know, there's plenty of articles about how to set this up, including on Saint Smart. But, you know, it goes into the A pin there, but then I have, damn this fucking thing. Anyway, I have this going into a European barrier block here that I cut in half, you know, cut out to be a 4x4. Then I have an alligator clip coming out of that, going over, you know, to this wire here. Now the other wire coming out of that is this black wire. It is hard operating a camera like this, because this is like backwards and everything. But at any rate, that's that black wire, okay, and I have it going over here, guys. Almost everybody I've seen use alligator clips, and they clip it like to the spindle. You don't need to do that. I have a wire here. I have it soldered to a piece of nickel, which, you know, anything conductive will work, but I have it soldered to a piece of nickel, and that's just pressed down in there, and then I just tighten this screw down on it. So it's not, this isn't actually soldered to the motor, it's just soldered to a piece of metal, any metal that'll take solder, copper, whatever. As long as it's flat, you know, you don't want it, you want to make your, you know, you don't want to interfere too much with your motor being gripped. But anyway, once you got it in there, just tighten it up, and Bob's your uncle. You can leave it like that. You don't have to disconnect it. And believe it or not, this body is always in contact with the spindle, always. So, and you can always, you know, test it if you just freshly set it up. I tested it. I'll take like one of the wrenches that came with it and just do that. Here, I'll show you. You know, if you see the machine here, if you look right in this corner right here, you know, it's going to register. So that TS :T. Okay, that tells you it's a good connection, but you know, you can do it right with the tooltip too. But once you do that, you don't need to ever worry about it again, because it does not stop the machine, as it turns out. I figured it would act like a limit stop, but it doesn't. It's actually a totally separate circuit, so you can leave that connected all the time. It does not interfere with the operation of the machine. So there's no reason to keep connecting it and disconnecting it all the time, because you will break bits like crazy by either forgetting to disconnect it or... What the fuck? God, I hate Windows. Fucking stupid ass Windows. Ugh. Fucking prick. Anyway, the fact of the matter is, you know, is that, you know, it works, and you can just leave it like that, because like I said, you'll either break tips, or more often than not, you'll end up almost starting a fire by forgetting to take the damn clip off of that thing. You know, so it's just better not to do it that way. Just leave it permanently connected. You know, there's no need to do it. I wish I could, you know, I'd make these wires better here. I'd like to get, like on my ShopBot, I've got a big little, like, a band that's in an arc of flexible plastic, and the umbilicals, all the wires and everything, I run along that. That's what I'd like to see, is something like that going here, you know, but I haven't got around to looking for that yet. But anyway, they need to wire tile your wires to it. You know, and a note too, you know, when running these machines, I tend to run them pretty slow. And again, you can certainly experiment with your own equipment to get it up as fast as possible, but this is not a very high-speed spindle. And these circuit board drills and circuit board tools are typically made to operate between 10 and 20,000 RPM. I mean, that's what they are actually used at in industry. They're really high speed. This is running at, like, I don't know, I haven't put a tachometer on it yet, but I mean, maybe 1,000 RPM or so. You can tell just by how it sounds, that it's not very high power. But if you actually look into these motors, I mean, these motors, this is basically the same motor they get out of a out of one of those battery powered, like, 18-volt routers, and of course they're powering this off at 12 volts. But you could actually literally just, if you didn't care if the machine controlled the motor, you could just basically wire this up to an external power supply, like a variable power supply, that was like, it better be a lot of amps, because these motors tend to draw a lot of current. But yeah, have something that'll go up to maybe 15 to 18 volts, but I don't think I'd run it that high, because these motors, being from power tools like that, aren't really built, the bearings and so forth in them aren't really built to run for extended periods of time, like an hour on end at a high speed. So that's one of the reasons they have it tuned down. The other reason is just because they're cheap and they don't, they want to have to provide a bigger power supply, because higher voltage would mean more current and would mean a much bigger power supply, because this really should have at least 5 or 6 amps. This is, I think, is only at like maybe a 2 or 3 amp power supply. I forgot. But at any rate, it should at least have 5 or 6 amps, preferably have maybe 8 or 10 available, for stall situations, that kind of thing. If you're going to run it at a higher voltage. But it could be done, like if you're going to drill holes, for example, and you wanted to do it really fast. If you took this up, usually it doesn't take, if this thing went at high speed, it could drill all these holes within a few minutes. You could run this at a much higher speed for a few minutes, without it getting too carried away, although I still don't think I'd run it up to the full speed. But a motor like this can typically go up to about 5,000 RPM, and you'd be way better off with that, with some of these drills. But still, I've had okay luck, at this speed. But but see, another thing you could do is you could actually build like a FET-based amplifier, because this is just PWM, so you could have that driving to like a FET amplifier. Then your separate power supply, would be modulated by that, which goes to the motor. That's another way, and then you still actually have control, both speed control and on and off control, like you do currently. So that's another way of doing it if you wanted to dink with it. But you should probably just buy a higher speed spindle, because they do have them for like $60. Anyway, that's enough said about that. But this is the basic process, though, of how you go about making a double-sided board here. So I'll see if I can think of anything else for a minute before we get started. And I guess, it's in order to say that, I have made thousands of circuit boards myself. I've been doing this, like I said, ever since the early 90s. Back then I was using, chemical etch with ferric chloride, and, came up with a lot of contraptions doing that. I was actually in a small-scale business doing that for a little while. That's what I'm saying. I've made, lots of circuit boards using lots of different techniques, including the, the iron-on technique with the paper, which I actually have my own version of that, which worked quite well, but it's not as elaborate as what people are doing these days. But I'm not quite sure if that technique really works with most laser printers anymore, because I don't know if the laser printers seem to put enough ink or something. Something seems to have changed, but I'm not sure. If the toner is the same or whatever. But still, but doing it with CNC, has certainly been a really great way to go. I've made some pretty large circuit boards doing that. Let me see if you can see this without it unplugging the camera. I don't know if you see that right there, but that's actually a digital sign in those panels I made on my K2, and those are like 12-inch by 6 or 7-inch wide panels, and they're like 4 of them in there. So that's a great example. Again, my K2 over there, which you again, can hardly see it's buried because it's on the other side of that monitor over there behind those wire spools. But at any rate, that is a machine that'll do, 12-inch by 12-inch circuit boards, and I had a vacuum hold down for it that I used to use, which is, again, why these things had holes in them. Those are for vacuum hold down holes. You see, there's one of the actual full-size pieces I used to use for that machine, but I don't use that anymore. I'm trying to use this for circuit boards because it's so much more precise because of that height mapping it can do. Because I couldn't make circuit boards like this on my K2. It's just not. I could with traditional, cylindrical routers perhaps, but even still, and if it was small like this, I could. But if it was like large, I couldn't do it. But this will height map, and it's mostly a software thing. I mean, in theory, you can make the K2 do that, but I'd have to write my own software for it. So I'd rather not waste my time on that. So I'm just going to use my K2, which is a much more powerful machine than this. For more serious work like routing aluminum and stuff, it's powerful enough to do that. This, I don't know if these, little 30-ounce or so stepper motors. I don't know if I'd, have a lot of faith in that. In the spindle in particular. Like I said, it's stronger if you want to run it at a higher level, but still, it's still not built for high-speed, long-term operation. Even though you can get more oomph out of it than this, I guarantee you. But I don't know that I'd want to route aluminum, but I have seen people do it, apparently with stock motors, but an updated spindle. But really, these motors are responsible for the feed force, and if you don't have a lot of force here, you could lose steps pretty easily. I mean, you'd be amazed how little force these things can actually apply. Under most circumstances, being such small motors, it does make sense to have a more powerful series of steppers, but they're NEMA 17s. You could upgrade them, but I don't know that your controller would be able to power them or not because it's got built-in little stepper drivers. But at any rate, the point is that if there's anything more, we'll mention it as we go. Oh, and one more thing, if you're wondering why I'm not using the expanded PVC on this, is because, again, and I'm just drilling directly into the backing, which I never do, it's because, like I said, I'm about ready to dismantle this thing. I'm not going to use it again, so I'm like, well, I don't care if there's a bunch of holes in it, and I don't want to waste any more of that than necessary, and I don't have a good piece to fit this, so because of that, I don't want to butcher one of my other pieces up just for this when I'm not going to use it anymore. So anyway. But if I were going to use it, like I said, I would put some of that hem tape on it, about 4 stripes across the back of it, and put it down into our baseboard here, okay, and then I would put tape on the back of this just like I did and tape it to that, to the expanded PVC. So that's how you do it. And you can peel it off again because that tape is permanent technically, but it's still pliable, so you can still peel it off even if it's been a month or more. So anyway, that's why I like that tape so much. Also, before we really get going here, I wanted to cover some of the stuff that you should probably have if you're going to do this kind of thing. One of the things, is you want a good, selection of these triangular bits. Now, I bought this for I don't know, $10 off of Amazon, but it actually has, I don't know if you can see that or not, but 20-degree bit, 220 degrees, 230 degrees, 245 degrees, 260 degrees, 290 degrees, and these are those triangular cutters that I'm talking about, not these things. But yeah, have yourself a set of these, and of course, you're going to want, like a set of router bits. And here is a set I bought again off Amazon for like $10 or so, which has a lot of different sizes. Typically, I've been using like the 1/16 inch router bit, 0.062 or so. But you can use any one you want. But that's just been my preference. Because it has a narrower kerf, so you get more use out of your board. Because again, I don't like to waste copper clad. I just don't. That's why I don't do it like other people do it. They'll cut the board, the copper clad, to roughly the size, and then they only got one loaded up. But this way, I can actually do several of them, okay, without having to change out the panel. So this just works a lot more efficiently. So you know, you don't have to keep fucking with your main board and backing and, you know, your waste board and all that stuff all the time. But you should have a good pair of calipers. This is inches and millimeter digital calipers. I bought this, I think, for 18 bucks from Amazon Warehouse, so I found a good deal on it. These are normally at 30 bucks. So nice little calipers. They work really well. You're definitely going to want like a little paintbrush so you can dust it off, okay, you know, kind of as you go, because it doesn't matter if you get it close to the tip when it's turning, etc. So that works great. And then oftentimes I'll use a lighted magnifier glass like this, which has got you know, basically visible light and also UV, which UV is interesting. See, you can see how what it's doing to the traces there. As it turns out, you know, when you're routing with FR4 or whatnot, boy, that backing really shows up through the light really well, so you can see if your traces have got any garbage in it really easily. I mean, I was really surprised, you know, how well this worked. I mean, that was quite a discovery there. Because I only just recently discovered that with this thing, but man, it fluoresces. The material I use fluoresces. So yeah, you can tell if you got any little copper slivers or anything in there that you need to dig out. And yeah, you should have some like dental picks, which I don't really have one lying around. You can use, you know, little razor blade tips like this, you know, which are for utility knives. Those work really well, you know, to try to scrape stuff out of there underneath a magnifying glass. It's a really good idea, though, to have yourself a, you know, one of those mag lamps, like I got over there, you know, to look at these under too, especially when you're doing that, so you can do it hands-free, because that's usually like a two-handed job. You don't want to turn it into a three-handed job like you would with this. So, or have something that can hold the board independently while you scrape it, but, you know, you have to apply force. So, but yeah, I would do that. And of course, you know, get yourself a good collection of drill bits wherever you can find them. Again, a lot of these I bought like 20 years ago at a place called Drill Bit City. Again, they were good price, but you can find some pretty good stuff off Amazon too. So, and myself one of these little things, you know, which work all right. Little magnifier glasses, and definitely a soldering iron of some kind, you know, is a good idea to have, and certainly miscellaneous tools like screwdrivers and stuff. So, but at any rate, you know, yeah, you want to have some basic tools like that. It's a good idea. Doesn't have to be lighted, but it helps, you know, a lot. If you're especially if you're trying to route it, because a lot of times I'll try to study the route, like when I'm doing V-score routing, just, you know, as it goes. So I'll brush the chips off with my little brush, and, you know, and try to make sure that it's actually scoring, you know, fully into the board, as opposed to just scratching the surface of the copper, which you run into sometimes. But at any rate, you know, yeah, that's at least a basic minimal tool set I'd advise you to have for doing this kind of stuff. And, you know, Scotch-Brite pads like that green one lying over there, you know, is a good idea. But what I found is that the best way to actually clean a board, because you'll have to do that. That's the other thing that I forgot to mention, that you know, when you're done with the first side of the board, you know, you've done the top side and you're ready to flip it, you know, you should clean off, you know, the top side before you put tape on it, because you want to make sure you remove any burrs, right? But the best way to do that is actually with a bastard file, just a flat file. And as it turns out, this is actually one of the best ways I've ever found to clean circuit boards. You know, if it's already routed, you do it, it just makes it. You know, you got to be a little persistent, but it's actually better than Scotch-Brite, so or sandpaper or something like that. But if you have a bastard file, you know, you can make this nice and shiny, you know, really, really good solderable surfaces. And by the way, you know, if you're doing soldering, but I don't know if you can see that, but that's actually exceptionally shiny with a very small amount of work. It is a really, really good way of cleaning not only the burrs off your board, but also getting all the smudges and fingerprints and anything else you may have on it off. But, you know, when you're soldering these things, yeah, you might want to get actually some liquid flux. No clean liquid solder flux is what you'd like to have. I'm sure you can get that off Amazon too. And just have a little syringe, like a needle syringe. You can apply it, you know, so you can get it like right on the pads. Because these things will solder a hell of a lot better if you do that. But, you know, if you're worried about like solder bridges and stuff, which I'm still really worried about things like this and the board we're about to do, given you know, the fact that I got some traces routed between a lot of the pins on the board we're about to do, not on this one, but on the board we're about to do, I've got a lot of traces routed between pins. I'm still really nervous about whether it'll actually be solderable because of all the bridges. But you can actually buy solder mask on like Amazon. You know, they have two varieties. One's kind of an iron-on stuff, and the other is this liquid stuff. And these German guys make a good video about how to do that. I don't know if I have the video up yet still or not, but
today I'm gonna.
Yeah, it's these guys. That's DIY Tech Brothers. They have some pretty good videos about, you know, about going in and doing things like applying solder mask and so forth. And like their own videos on double-sided boards, but again, they do it in a more traditional way, so as opposed to the way I'm doing it. But yeah, you might check their site out if you're interested in some of that solder mask. But you can buy that off Amazon too. Although the syringes don't come with a plunger on it, you know, the ones on Amazon. I don't know how they get around that. So, you know, so I don't know, you know, but you can find it on there. It's, you know, it's available, but I've never tried it. So, the last time I used solder mask, I used to use LPI, and that was actually the professional grade stuff that they actually used. You know, you'd silk screen it on, you'd blank screen it on, and then, you know, do a photo exposure pass, which you could do in sunlight or whatever. You know, it's doable, and then you use a chemical to remove it, and you know, and that isolates your pads, and it works really well. In fact, you got to be careful if you ever find any of that stuff. You got to be careful because it may look removed but not be removed, and then you can't solder to your pads. So, you know, you got to make sure it's not like overexposed or anything. But at any rate, you know, I digress. But let's get back into the video because we got to get you know, this Flatcam stuff done. I've already loaded up the layers on it. As you can see here, I could just start a new project for you. Step the camera aside just to show you how I actually went through the whole process if you're not familiar with Flatcam. You know, this Flatcam has some bugs in it that really piss me off about directories. I don't know why they do it, but you know, let's save it. Yeah, so if you got, you know, you start a new project, okay, in Flatcam, and it takes a little bit, but you know, okay, here we got a blank new project, but it's not saved down anywhere, so press Control S. You know, you can go in and fuck with this little fucking menu thing, but that's a bunch of crap, so I just press Control S. Okay, and for some reason it goes to this directory. I don't know why, but that really pisses me off. It's not a working directory. So I gotta come up to our working directory, press Control C, and then come and copy it over here. Can't understand why these guys can't do something simple like that. But maybe, you know, this isn't quite the latest version of it, so maybe they corrected that by now. I don't know, but it is a slight pain in the ass. It's just unprofessional. but you know, here's where I'm storing these projects for this particular deal. So I'll basically call it shorter 2 because that's the one I was working on. I wasn't intending to make this video at first, but I decided to right in the middle of it. Anyway, so we got a new project and it's saved down. Now we got to go open it up and oh, guess what? We're back to this fucking directory that doesn't make any sense. So I got to go do that again, and eventually it gets the fucking picture. But anyway, here are my Gerber files, and again, you know, I generated this from KiCad. So you know, KiCad, you know, you got the deal here, and you just go into plot, okay, and that brings that up, and this is what I exported at, in case you're familiar with KiCad. Now, KiCad, a lot of people don't like it, and I can understand why, because it doesn't work really like other programs, and that pisses me off. But if you take like 15 minutes to get used to how it works, and learn what the, you know, the keyboard key, the hotkeys are in it, it's actually a pretty good program, surprisingly, especially for being free. But at any rate, these are the layers I typically convert to Gerber, and for this I have some mounting holes, and I put it on the drawings layer because, you know, instead of the edge cuts layer, you know, I actually have them on the edge cuts layer in KiCad, just so the fills will route around them. But this right here is actually, you know, see, that's the edge cuts layer, alright, but this is the drawings layer, so I actually put these separately on the drawings layer, so I can use those with Flatcam, because when you're doing the edge cuts layer, it won't recognize internal features like RhinoCam used to, for example. So I used to do all my stuff in Rhino and RhinoCam, but those aren't free packages. But at any rate, that's why I actually am using, you know, a drawings layer for my mounting holes, just so I can route them as a separate operation. But this is the bottom copper layer. This is the top copper layer. I don't know why I call it front. You know, it's front and back. You know, maybe that's what they mean, front and back. But it really is traditionally top and bottom. So, but at any rate, you know, yeah, this is the top copper layer, this is the bottom copper layer, this is the edge cuts layer, and this is our silkscreen layer, which I don't use. So, but I still print it out anyway. I'm still interested in trying to actually, on a single-sided board, actually try using a router and using the same flipping technique on a single-sided board to actually physically route the silkscreen into it. I haven't tried that yet. I'm going to try that at a later date. I won't be able to use a leveling routine on it, though, because there's no metal on the back side of a single-sided board, so I can't level it. So I'll just have to use a really narrow bit or something and get lucky if I ever do that. But anyway, but still, we're interested in these 4 bits here, and I'll open those up, but let me finish off first what I was getting to here, you know, in KiCad. So like I said, you're doing these layers, you just press plot, it automatically generates it. I usually uncheck this Gerber job thing, and then I check use auxiliary origin, because when you're putting your origin on a double-sided board, on a single-sided board it's not as big of a problem, but because you're using that leveling routine and candle, it's best to offset the origin little over 1 millimeter from the bottom and little over 1 millimeter from the left-hand side. And I'm just left-handed. You can probably do it in any corner you want, but anyway, I do it 50 mil in and 50 mil up. So, because I don't work in millimeters, I work in mils. So, anyway, the fact of the matter is a mil is 1/1000th of an inch, if you didn't know that. But, yeah, it's 50 mil in, 50 mil up, and that's where I put my origin, you know. Because otherwise, if you didn't do it, if I put it right in the corner, the thing is once you routed the first layer and you flip the board over, then you go, you know, solder your little connection, you know, so that it can do the height route. on the board. The problem is it'll tend to follow, you know, wherever your origin is, and if you don't have, you know, if your origin's here, but you've already routed the board, the edge of the board, and you will have, there's a good chance it's going to just crash that bit right into a hole, and you won't understand what the fuck is going on, and it could screw up your, you know, make your thing miss a step and everything, and you have to go and try to realign everything, you know, it could throw your stepper motors out of whack and make them miss a step. So anyway, just inset it enough to where that's not going to happen, because, and also you can see the border I have around this board, you know, I had to add that too, and this is again 50 mil on each side. So, you know, I've got my program set to a 25 mil grid, so it's like 2 steps. So, you know, so basically, yeah, you know, you just offset at 50 mil on each side, because when it, you know, when you do your leveling, you know, you use like one of your copper layers, like, you know, your for example, your bottom layer when you're doing the bottom, and your top layer when you're doing the top. But it'll actually, when you press auto, it'll actually go in and grab the copper itself, and it still insists on starting with the damn home point, no matter what. There's nothing you can do about it, so you better inset that, is what I'm saying. That is a crucial thing to do, to make sure you have a good border around the entire board. And like I said, this board is like, well, let's see how big it is. Let's see, I got my, go down to the very corner here. Let me just grab this tool just so it hooks to it. I'm not going to use the tool, but what I'm going to do is I'm going to press space bar, and that resets my DX, DY coordinates here. So, and again, you could have done that with a wire tool or whatever. I'm just using it as a convenience to get blocks onto the snap grid. But then let's go up to the upper corner here, and you can see, you know, looking at the DX, DY, that it's 5.92 inches tall and 2.32 inches wide. And again, that's something stupid this program does that nobody else does. You cannot reassign the absolute machine origin on this fucking thing, so that's why it's in negative coordinates, and no CAD program ever does that. So, but I'll tell you what, programs do it by default, and that's programming languages. They tend to do that work with graphics, so somebody was too lazy to fix that so that it works properly. But normally you can reset the absolute origin in any fucking program I've ever seen that's a CAD program. But at any rate, you know, TCAD does work a little funky, but still, once you get it, I spent about 20 minutes or so learning the, you know, the key combinations. You know, you can assign, you know, any keys you want on it. Again, good luck finding out where the damn settings are, because there's like 3 different places. This is another thing you're going to want to set, you know, is your clearances, your track widths, vias. I usually set my clearance about 20 mil for CNC like this, but to route between pads, like I did on these ICs, you know, again, this is the first time I've ever really tried this. I'm just not sure how well this is going to go. But I got, you know, traces actually routed between the pads. That's why I'm going to use a real narrow-tipped a V-score router. You know, I normally use like a 45 degree. I'm going to go down to a 30 degree on this one, just give myself a little extra tolerance. Because the clearance on here is like 5 mil. That's about the only way, because these traces here are 25 mil. Again, you don't really want to go much lower than that, because a lot of times, you know, these V-score routers will tend to overcut, because it's just, you know, the deeper you end up going, okay, the wider the kerf is going to be on that. You can cut through your tracks, like if the mapping part of it, you know, had a fart or brain fart or something while it was doing it. Okay, well, you know, you could end up screwing up a whole board just because one little area's coordinates is all screwed up. So it's best to, you know, give yourself as much leeway as you can. Make these traces as big as you can. Normally, I don't go any, you know, on most of the boards I've done, I don't go any more than 50 mil. And that's what this is. Ah, damn it. I'm still on that stupid origin thing. But, you know, normally, you know, these are like 50 mil traces. Normally I try to stick to that or larger, but, you know, when you're doing things like this, you know, you really got to go down to 25 mil. But I don't recommend, you know, going down to, you know, you see these are all the settings I've programmed into it. So as you can see here, And again, I'm just doing that for benefit of people that maybe are a little familiar with KiCad, but don't know for sure all this stuff. Let's see. The design rules, the fraction B is right here. I set these all up, but in order to set the defaults in this stupid program, you gotta, it's complicated. You gotta go into your source directory and create a project, and then go edit the defaults and save that down as your default template. So anyway, it's just kind of complicated. I'm not going to get into it here, but that's how I set that up, and I set the via size up to about 90 mils. Again, you want to give yourself as much area to solder to as possible, because again, solder bridges are easy to form. The bigger the pads you have, the less likely it is you're going to form a solder bridge. And by the way, on your iron, try to get yourself a real narrow chisel tip. Like, for example, this is way too, you can see this, this is way too large of a chisel tip. It's good for heavy duty soldering, you like stuff like that, but you know, you want really a narrow chip, a tip. And again, you can get those, you know, on Amazon too for pretty cheap, you know, for different soldering irons. Anyway, I gotta go reset the stupid origins since I accidentally messed up on it. Okay, that's how you set the anchor for the origin, the alternative axis that you see, you know, here when you push this use auxiliary axis. That's what I just placed as auxiliary axis. Anyway, you go plot that, and then you can go into the generate CNC files, and I just leave all this default and just hit generate, right? Okay, and it'll generate your files. Now you should note that when it comes to drilling holes, and I'll explain this when we get to Flatcam, but I really only use one drill bit. Sometimes, you know, and that's the drill bit I typically use is like a 28 mil drill bit. You know, it's like one of, God damn it, stupid cursor. Yeah, but it's like one of these. So, but yeah, it's a finer drill bit, but it's good for most IC pins and even 3-terminal regulators that are in a TO. You know, most TO220 chips will fit into that. Oh hell, I shouldn't have closed that. Most TO220 chips will fit into that just fine, and you know, so it's pretty good for, you know, it's pretty good for most tasks. Now, if you're using like a 1N4001 rectifier or something like that, you're going to want to go to a bit more like that other size I used, you know, that I was using for our little reference holes there. You know, that's what I used for that. Is that you know, that bigger drill bit there, because that's like a 42 mil tip, and that's good enough for most rectifiers. And of course I do have bigger bits too, but I just rarely use them. Usually if a hole's big enough, like some of the holes the mounting holes we're gonna use, I'll just use this router bit. This is a 16th inch router bit. I'll just route the hole out instead of drilling it. But that way it just saves you, you know, a bunch of tool changes. Because let me go ahead and pull this up. This Epsilon file thing, we need to load the Epsilon file for this, and it's coming out of KiCad, it's the PTH file. This doesn't do anything, I don't know what the hell it is, but you know, that brings in our drill holes, right? So you know, you can see how all that's lined up. Going to the Epsilon router. Now these are all the drill bit sizes this thing is using. And in order to change this, I would have to go edit the entire fucking library in KiCad. Now, I could probably make a Python script or something to do it. I'm not that experienced at Python, but it's a simple language. I've gone through training on it. It's been several years since I really touched it. But, you know, this is all text files in KiCad. What's kind of nice about it, you know, because you can manipulate the files, everything, even the job files, all the libraries, everything's in text files. So it's possible to go through and write like a Python script that just, you know, changes all this shit out. But that's just such a pain in the ass. I usually never mess with drill bit sizes unless it's something special. But you know, I do have the diode sizes set at a different hole size and so forth, so I can single them out If I wanted to actually generate 2 different drill hole sizes, how I would do it is, let's say like this thing here, which is a capacitor. You know, I got 2 capacitors here. One's a, like a, I don't know, 10 nanofarad capacitor or something like that, and this is like a 1 microfarad, just for noise suppression, because these are high-speed counters. What this board is, by the way, is this is actually a timer board. Let me pull up the, how I made this was really kind of funky. This is the actual schematic for it. But this is a series of cascaded sections. These are 74, either HCT or LS or whatever family you want to use, 161 timers, which are rated at 35 megahertz. Okay, and this is a shift register, which is an 8-bit shift register, a 166, LS166. But at any rate, these work in cascaded fashion. So these are 4-bit timers each, but 2 of them together make an 8-bit timer. This is an 8-bit shift register. I'm going to combine 4 sections to make this a 32-bit timer with a 32-bit shift register. I'm going to hook this up to an Arduino, so that basically I get essentially the ability to either time or count, like 25 megahertz signals, etc., or up to 35 megahertz total. So I can use it as an event counter, which means I can count 4 billion events, in however many hours it takes to do that, or whatever, whatever period I want to select with the Arduino. Or I can actually hook it up to a frequency source, like a 25 megahertz crystal oscillator, okay, and count that and use it as a timer. So I can time real precise events down to, like, for example, 125 millionths of a second. So, like, if I were going to, use it for, well, there's just a lot of different, I'm not going to go into the applications right now. But the fact of the matter is, there's 4 of these cascaded together, but instead of just making the schematic huge and to have to go in and really position each and every one of these fucking parts in an identical way for the whole thing, I just decided to use the duplicate function, which is like Control D. So I just did the first section here, and then I duplicated it 4 times to make sure everything was lined up. It was a pain in the ass, but then I had to basically reassign some of the pins to a different net, so that I could route them with no problem, since they deviated from the first module. But anyway, it was a pain in the ass, but it got the job done, and that's why you see a bunch of unrouted nets here, but they're not actually unrouted. It's just that when you do Control D, it kind of copies those nets. Now, if I didn't do the Control D, if I did Control C, and cut, copy and paste, it won't copy the nets. So what'll happen is your little fills, your fill layer, will ignore them. So if you want to actually have the fill layer be aware of what net a given pad is attached to, you got to use Control D, even though it creates a bunch of unrouted traces. Just make sure you get your first one just completely bulletproof. You double, triple check all the connections. Make sure you get all the, the electrical bridges, taken care of, because some of these pads are broken off from each other, etc. So just make sure you get everything, together before you start duplicating it. But once you do, then, it's a little bit of a headache, but it works. But that's how I created this, by the way. I just didn't feel like going and redundantly trying to route like 500 different nets when really they're just copies of the same damn thing. Now, there may be another way of doing this I haven't discovered yet, but again, it's KiCad, so I don't know. But at any rate, that's how I did that. But yeah, I just, when it comes to drill bits, like I said, I really only just use one drill bit. And like I said, if I were going to do that on this board, what I would do, and let's say like this C4 type capacitor, let's say I wanted that to be a bigger hole size, what I would do is I would come back and just erase everything but these, okay, and then replot the Exelon file, redo the drill file. So, and then it would just include those components, and I just use that as a separate drilling operation. So if it's a bigger bit, it's not going to hurt if there was a smaller bit that already drilled the hole first. So, in other words, my first pass, it would drill all these holes, every hole you see here. But then I would load the next file, okay, into Flatcam, and have that do a trace just for these particular holes for these C4 capacitors. Okay, and yeah, but since it's a bigger bit, hey, the holes are just pre-drilled, and it'll just drill them out a little bigger. So that's how I would do it if I wanted to actually. It's a bit of a pain in the ass. The other way you can do it is, again, I've got like a shitload of different drills. I mean, I could put check tool change. If I did that, that'll make a tool change point in it where the router, the CNC will go back to its tool change position. Then you got to put a new bit into it. The problem is it would do that for all these times, even though I'm only going to use one bit for all of these. So I sure wouldn't want to do that. And even if I was just going to change it once, I still would not have to go through a tool change for all of these. It's just a little bit of a pain in the ass. I'd rather, just set it up to drill a hole and go in and, watch TV or something while it's doing it instead of having to sit here and nursemaid it. So it's just better to do it that way, than to go through a whole tool change thing. In my opinion, but you can do it your own way. But anyway, I'm getting ahead of myself a little bit. But let's go. What the hell? Okay, but anyway, we've got all our stuff loaded in Flatcam. One of the first things I tend to do, just to get it out of the way, is the edge cuts. Now, before I go into this too, I know I left something out I wanted to show you on KiCad. Before I get too far away, I wanted to show you what the different preferences were. You got a preference setting here, you got a preference setting here, which you've already seen. But if you want to go in and find the hotkeys, okay, this is where you set the hotkeys. You can assign any of these items a different hotkey than is set by default. But again, my advice is try to learn it, like it's learned by default. And you can press F10 or something like that, and a list of these will show up. But unfortunately, these dipshits made these windows all modal, so I can't like go work on them, on something else while these are up. So I can't, for example, bring up, the list hotkeys. Control F1 is where it is. I can't list this up and just bring this up and just set it on the side because I made the damn window modal. So you can't leave shit up, so it's best to, copy, those hotkeys to something like, something like, sticky notes or something like that, put some stuff like this on it. If you want to, but it's not too difficult to get used to these hotkeys. But once you start, get used to it, this program's still actually fairly efficient. Again, I really ought to make a separate video on how to use a KiCad, but it would be rather lengthy. But it actually is a pretty efficient program. I wouldn't use it if it were too big of a pain in the ass. I can't stand things being too big of a pain in the ass. And there are some pain in the ass aspects to this, but it's still not quite as good as my old program that I've used for like 20 years, which was Protel, a program made by Protel called Circuit Maker. Tracks Maker in particular, and Circuit Maker was a schematic capture version of it. This program I still actually use from time to time. It's real good, it's real efficient, works very intuitively. If you've ever worked with any kind of CAD or graphics program, it's about as close to that as you can get in a circuit board program. But they don't make it anymore. And this is like a 2000, see, Circuit Maker 2000, if that tells you anything. But it was made by Protel, aka Altium. It's a low-end product back then. In fact, I actually bought this program from Jamico, so for like $600. But yeah, it's a decent program. It's got a few bugs in it, but the problem is its libraries are also out of date. Nobody does anything with it anymore, so but it still works. You can still generate programs for, like Gerber's for, Flatcam or whatever. It works with it. So I still do use it from time to time. It's just you know, trying to update something a little more modern at least. That's still simple and free. But at any rate, you know, that's where you know, the hotkey settings are. So, and again, there's one other little area that has settings. That's interactive router settings. So, in your circuit board part, that's where the 3 settings areas are essentially. So, you know, and I've used shove auto routing, and you know, because it doesn't auto route, by the way. This KiCad does not have a built-in auto router, but its manual router is still quite good. So when you're doing, you know, net routing, you know, manual net routing, it's still quite good. But they do have an auto router available for it, but it's a separate program made by a different manufacturer, different, well, not manufacturer, but a different open source supplier that's designed to work with KiCad. I haven't tried it yet, but I guess it's pretty good. I don't know. But at any rate, that's enough about KiCad. Let's see. Like I said, I told you this video is going to be long, and it's a single cut. I do have like Corel Movie Studio, which works great, but frankly, I made like several hundred videos for YouTube, and frankly, I wouldn't have if I had to go through the whole process of cutting them all together, splicing them, and compiling them, and you know, doing the cut scenes and all that crap. I mean, I just wouldn't do it. It just takes too much time. So I always try to make videos these days, you know, as single cut videos as much as possible. That's what I'm doing here. You know, I mean, right now I'm using actual Corel Movie Studio's little, you know, Corel Screen Capture here, if you can see that, which is a nice little program. It makes really small files, video files. That's what I like about it. But it's part of that Corel Movie Studio package. But you know, you can resize the screen to whatever you want pretty easily, and it's an efficient way of doing it. But at any rate, yeah. See, we got our, you know, we're going to start working on our, you know, on this edge cuts layer, you know, which is this outer layer here. And by the way, you know, you can go in here and, like, for example, I can, you know, hit Shift Select, you know, and disable a lot of plots. Okay, so it makes this stuff disappear. It's still there if they're just disabled, so it doesn't plot them. So, but you can see that we still got like the edge cuts layer and the Epsilon thing up. But then you know, re-enable them, and plus too, since we're doing a double-sided board, I'll usually just set the color. But here, I don't like it being too extreme because your holes will disappear. So I like going, and instead of making like red and blue, you know, I'll go like what? Okay, this is the top side, yeah. So I'll make my top side like salmon color, okay, and then I'll just so it's not too extreme. Because see, if you make it like an extreme color, you know, you'll get, you know, this. Okay, where are my holes? My holes are gone. So. So again, that's why I do it. You know, it's a bit of a pain in the ass, so I wonder if you could set the defaults on this. I'm not sure when it comes to colors. But yeah, so I'll do salmon for the top layer, and I will do a lightish blue for the bottom layer, something like this. So this makes it a little easier to see. Yeah, those are about the first things I'll do. And at any rate, then I go get back to the edge cuts layer, and again I'll take care of that first. Oh yeah, these are, by the way, the defaults, the preferences. The preferences settings are extensive on this. They're under the edit menu, but you can set like all kinds of things. See, these are all different tabs: general, Gerber, Epsilon, geometry, CNC, tools, utilities, etc. But yeah, several of these things I've set the defaults on, because by default this Flatcam thing's in millimeters, which if you're a millimeter person, you probably like that. But yeah, I mean, and like I said, you got to scroll down, make sure you don't forget these scroll bars are here. So, because like I said, there are a lot of settings on this thing, and I'll commend them for that. You know, it's good they made this comprehensive. Unlike KiCad, which honestly really lacks a lot when it comes to settings and preferences. So I wish KiCad was more like this. Because honestly, even trying to find some kind of file where all the real true nuts and bolts settings are, I still haven't been able to find it yet. Either in the registry or in some kind of file, so I have no idea. Where you modify really basic stuff, except that of, like I was talking about, creating a template job, in the main directory. So in a template job, if you press like, open existing project, but you got new, create project from template. Okay, this is a template job. And here are a couple of templates I've created, okay, which have all the default settings, but you got to go edit these template files, which are in the root directory. So it means you can't create them on the fly because, you need permissions, and this thing doesn't work with permissions in Windows. Even if you open it up as administrator, it doesn't matter. So anyway, they go out of the way to make it such a pain in the ass. It's unbelievable. Just simple little things. That shows you that that's the difference between professional software and amateur written software, because amateurs don't take the time to do the boring stuff. That makes a program really usable. Just little things that tend to be really aggravating. But at any rate, setting that aside. Yeah, but setting it aside, I just wanted to kind of show you these are here, and they are extensive. I didn't change any of the preferences. Okay, but yeah, on this program, it's like the right mouse button, is what you use to like pan your view. So, of course, it's the middle mouse button on KiCad, so I don't know if there's any way of changing that. But you can use a mouse wheel to zoom in and out, okay? So I keep trying to use the middle mouse button to pan, so that's annoying. But anyway, let's get back to doing our first layer, which is this edge cuts layer. So what I do is that I'll try to use the cutout tool instead. You can just use the edge layer, but I've already got this. You can route it like a standard object, like it was starting to do. But when you're doing this, this edge layer tool is kind of nice. You can put like gaps around it. Which, if you don't know what that means, see, I got the gap size set to 20, and I got it set to top and bottom. But you can actually have it left to right, or on like 4 sides, or 2 on the left, 2 on the top, things like that. So if I were to, and I wish they had a damn preview button in this. Again, maybe the newer version of this, maybe they do, but they really need a preview button on this thing, on this program, this Flatcam. At any rate, you go hit, generate rectangular geometry, for example, okay, and shit. Oh, God damn it. Well, I guess I gotta go regenerate all those damn files again. Yeah, apparently I forgot to change this stupid program. It's one of the other things it does I don't like. Even if you draw it with this graphic polygon tool, it still treats this like a bunch of separate line segments. Shit, I changed the fucking reference again. There's no way of changing the goddamn color of this damn thing, so make sure it's not set to something it shouldn't be set on when you're doing shit. Like I said, I can barely see that. I wish I could make it like bright orange or something, but I haven't been able to find a place to do that. And, piece of crap. Yeah, this is the way you gotta fucking resize the thing. It's usually better just to draw a whole polygon all over again. So let me go ahead and generate the, I'll just generate the damn, so I don't think it'll affect anything. I'll just do it all over again, and let me go back to Flatcam, okay, and then take this, press delete, and I'll open that again, edge cuts, okay, now that's gone, alright, so, that's why I was having trouble, but at any rate, yeah, you could, do it as a typical Gerber object, or you can use the cutout tool. Like I said, we're going to use the cutout tool, but make sure, let's see, this is your Z depth, this is your tool diameter, which like I said, I typically use a 62 mil router. And when I'm doing a single-sided board, I'll do it that way and this way. But since I got tape holding the board down, I'm not going to do it, but I want to show you what this does first. I'll show you the long layer. So, it says edge cuts there, okay, but if you go to the cutout tool, sometimes it grabs the wrong fucking layer. So you gotta make sure you grab the right layer. Okay. Now, generate rectangular geometry, okay, now, these right here are what those tabs are, so basically this is the routing path, so it'll route everywhere except for this tab on the bottom and on the top. And again, you can change the width of that tab, you can put, like I said, 2 on each side, or you can do custom tabs, etc., so that, if you didn't have tape under your board, for example, while you're routing through your board, if you don't keep control of it, you can end up breaking your router bit, destroying your board, a lot of stuff, because once this thing finally cuts loose, your router's still running, particularly if it's routing yet another pass deeper than it's supposed to, because you set it like 100 mil when you're depth, when you're only doing a 60 mil depth board, but you're trying to make sure it positively routes it. If this board breaks loose, it can get in the way of your router, and your router can start cutting holes in it. It can cause the board to go flying across the room if it's a small board, etc. But since we're taping our board down, we don't have to worry about that here. So in this situation, I'll, I will just, go to the cutout tool, and I will not, put tabs in it at all, because I don't need them, because it's taped to the substrate there, to your backing board. Now here, I'm going to do something a little different. Again, these are the settings I typically use, although I've got to change this into defaults, because these days I'm only going 80 mil instead of 100 mil depth. Oh shit, not 800 mil. 80 mil instead of 100 mil depth. Because it's 62 to 64 mil board, although this is probably more like 66 since it's double sided maybe. But the fact of the matter is that that's more than plenty, because of the height mapping. And without height mapping you want at least 100 mil, but with height mapping you can do it as little as 80. And then it's set to multi-depth, and what that means is, and I got it set to 20 mil multi-depth, it'll keep cutting a 20 mil depth route over and over and over again until it reaches 80 mil. So in this case, 20 mil divided into 80 mil depth will be 4 passes. So each pass will be 20 mil deeper than the last, so that doesn't bind your bit too much. And again, you remember, especially here, we only got this tape down, so you don't want to apply too much force anyway. And with the 3018, you don't have much force to apply anyway before your stepper motors will start missing a step. So it's highly recommended that you cut it in shallow passes when you're actually going through the board, and that includes even doing these holes, which you're going to find out a few interesting things about that here in a minute, which I've already alluded to. But here, since we're doing a double-sided board, and because of that little grid problem that I had, in Candle, because right here is where you got the height map, okay, and this is a height map grid. My original version, I generated this whole height map here, and when I got to the end of it, but it was about to run off the edge of my, my board. So it was just a little too long. That's why I had to kind of trim this thing down and make it a little shorter. Because yeah, it was about to walk off the edge of the board. So, but the other problem I ran into, like I said before, with that first double-sided board I showed you that I did, is I put the home point in the wrong. I put it, like I said, in the actual corner of the circuit board instead of inset like this. So I had a bitch of a time when I got to doing the top side of the board, because it was trying to height map it and walk off the edge of the board, because this home place, I'd already routed the board, obviously. That's how I flipped it, right? So, but the problem is that this point actually was in midair at that point, because the router bit had actually over-routed slightly. So that's why you inset your corner a little bit, so you don't have to worry about that. And again, on a single-sided board, it's not a problem, because you don't height map it twice, but you got to height map it, for the bottom layer, and then again for the top layer later on, so you got to make sure that you got copper underneath this fucking thing, or your bit will crash. Because again, it won't think it's running into any metal, so it'll just keep going and going and going, and and it could break your tool, or again cause your motor to your stepper motors to be miss a step or something like that. So again, it's not a good idea. But at any rate, that's one of the other reasons. As an extra precaution, I'm going to, instead of using 62 mil, which is my actual router size, I'm going to make this 100 mil. Okay, so that I get a little bit of extra depth, and let me show you what that'll do. Again, we're not going to use this. Our Z depth is going to be 80 mil negative. That means below its supposed surface. And then our 20 mil, per step routing. And then you can do freeform geometry if you had some kind of odd-shaped board. Apparently, I've never done this, but for this board, you just hit generate rectangular geometry. And here's down here, if you wanted to, those gaps I was talking about, you can actually add your own manual gaps too. Apparently, again, never tried that before, but I've seen those German guys. And that
to show you how you can create double-sided PCBs on your CNC.
Those guys, kind of show you some of that in a little bit, because they actually cover Flatcam a little bit, single-sided and double-sided. They're all right videos, and it's worth a watch. Okay, but yeah, let's go ahead and generate the rectangular geometry. Okay, and that's what it does. So you can see our path, and since I chose no tabs, we don't have any tabs here. But now, notice, if you can remember, the last one I generated was smaller than this, because I chose a 62 mil bit, but here I made it a 100 mil bit. So when so it thinks the bit's a lot larger than the actual bit I'm going to use, because I'm still just going to use a 62 mil bit. And what that'll do is that'll give me a little extra room, and it'll make sure that my actual route does not actually touch this border. And again, it's probably an unnecessary precaution, but again, I'm still paranoid about the pain in the ass I went through because of trying to do that height map, with fucked up coordinates. I'm just trying to hedge my best to make sure that's not a problem. In the future, I may not do it this way, but for now, it's safe. So, but at any rate, it just generated user. What the fuck is this? It's one of those things that did wrong, I guess. But at any rate, yeah, we just generated this, so this is our pathway. So it's right here is where you go in and generate the CNC job. Okay, what we did before was just simply generate the path. Alright, so that's how this works. You take a Gerber object, right, and then you generate a path like we just did, and that generates this object, which is considered a geometry object. Now this is the last step before it generates a CNC job. Okay, and that's kind of a little confusing, at first, but you get used to it. But that's where we're at right now. And see, we got our Z-cut depth, make sure that still says 80 mil, multi-depth 20 mil, okay, etc. tool change, etc. So then we go generate CNC job. Alright, and so that's generated our path. So it thinks we're dealing with a 100 mil width tool, and that's the path that will follow. This yellow line is its starting point. So start here, and then it'll go here, and then start doing its job basically. But at any rate, it's generated a CNC deal. You can either view the CNC file if you want, and this is the actual G code it generates. And G code is really pretty simple once you get used to it. It's still a pain in the ass. I'm still looking to see if I can find a graphical G code editor so I can actually go select a path and have it highlight it in code so I can cut it out or copy it or something. I've still not come across a program like that. I'd be pissed off if I have to write one myself in C# or something. But at any rate, you can actually view the G code if you want, and you can edit it, I think. Find in code, print preview. Print preview, I guess that means. Oh, that kind of print preview. So, okay, I guess you can print it out on a printer. I was thinking maybe that was a 3D plot of it or something, but I guess not. But anyway, let me close this, and you can just leave it up and go back to plot area. These are tabs up here. But let me hit save CNC code, okay, and that, and these are previous ones that I made. Again, I said I did it before, it was too short. That's what this is. So I'm going to go ahead and, oh, son of a bitch. Should just do this in the up here, but a lot of times I'll copy and paste things in these windows. It's more convenient, but I will have to do it over again if I change the name. Okay, so that's the name of it, for a cutout board. So I'll just say this is the default name. I usually don't tinker with it that much. So anyway, that's got our cutout layer done. Okay. Now the next thing I want to do, let me go hide some of this stuff. So we've already got that done. I'll leave that up there. Okay, yeah, user drawings. That's what I'm trying to get to. But let me go ahead and hide these two things just right now, so it'll be more clear to you what's going on. Okay. Now, next thing I want to do is this user drawings layer. Now, like I said, I told you that, you saw that I did the edge cuts layer, right? But it totally ignored those holes. And it would have done that even if I'd done it as a Gerber object for reasons that I'm not going to go into. But let's just suffice it to say this is the best. Well, the way I'm going to show you is the best way of doing this. Is you're just dealing with a different Gerber layer, and in this case it was the drawings layer, like I said, on KiCad. You can on KiCad you can have
CNC with Flatcam.
Oh, god damn it!
I'm going to walk through all the steps necessary to go from Gerber files to ready G-code files that can be handled by your CNC.
God, I hate.
And I'm also going to
I hate YouTube, and I hate it doing that crap. I'm not going to go into it. I'm not going to go on a rant. Anyway, just wanted to close that piece of shit. Okay. Sorry, I'm like borderline autistic, so it's hard for me to do this kind of shit, and shit like that bugs the hell out of me. So, let's see. Fucking, I forgot what I was talking about now. Oh yeah, in KiCad, like I said, you can have all these different layers, and there's actually more layers if you can figure out. Let's see where the hell it was. It wasn't settings, preferences. That's what they call it. No, it's not. These fucking morons can come up with a consistent way of doing things would be nice. Yes, I don't think it's here. Maybe it is, I don't think it is. Oh, yeah, it is. Okay, yeah, see, this is a layers deal, so you can go and set like the different layers you want to have. I don't know if you can add a layer to it or not, but this is where you set some of the layers. And like I said, you can have these different layers you can draw on. So, but again, I've been using the user drawings layer, whatever the fuck that is. Yeah, right here. I guess it only has one drawing layer in it. But at any rate, you know, it's just best to draw things like that on a layer such as that, and then you can, you know, again, when you're exporting it as a Gerber, you know, you can select that as a Gerber object and bring it into Flatcam. And in this case, it has our holes on it, so we can go and again, you know, select that Gerber object. Okay, and I'll typically, you know, here we're going to use a router bit, so, you know, but I'll go ahead and set it at 62 mil, you know, for the actual router bit size, because this isn't an edge router. I'm just trying to route these holes out. So, and number of passes, that doesn't mean the same thing as in multi-depth, so just leave this alone. I'll show you what that means later when we're actually routing some traces. But I typically don't worry about this stuff. Now combine is something, again, you can set that in the settings like I showed you earlier. That's something you should set, because by default it doesn't do that. So, and that's a problem if you're actually using this. If you're not, it's not going to bug you, but if you ever do want to do multiple passes, and I am going to do it on one of these boards, because what it does is it'll create more than, but I'll show you later. It's just going to confuse you right now. But right here, this isolation type, that's what you really need to pay attention to. I need to set it to, oh shit. Okay, no. I was going to say, you know, if you had, like on the cutouts object, if you were using just this type of routing method, not the, you know, not the cutout tool, but the regular screen here, you would have to make sure this was set to external so that it would route around the outside of the board, not on the outside and the inside. So, but for this we got to set it to internal, so I'm trying to just route out the inside of these holes. And let me show you what happens if I left it as full, so you can just see, and a lot of times you may not realize this is happening until you're actually milling something, and it sucks, and this is something you need to keep in mind. Okay, see what it did? Okay, it generated a circle on the inside of our target circle and on the outside. So there's a path on the external and the internal. We don't want that. You know, that'll make the hole way too big. Now, if you were to have done that on the outside, again, you know, I can generate, you know, an edge route, you know, for our you know, for our damn it. You know, for a router bit, you know, I can actually, you know, generate this edge route with, in the same way that I did these holes, or, you know, I can use the cutout tool. And the cutout tool, that's why I like it, because it already automatically knows to just route on the outside, but you can't route, you know, internal holes and shit with it. So, at any rate, I'm going to go ahead and delete this plot since we don't need it, because that's not what we want to do. We want to route just the inside. Okay, so generate isolation geometry, and that had the, let me go back and look. Yeah, that had, you know, tool diameter. Again, we don't deal with the depth here in that screen, but we deal with it in here. So, you know, because this is our Z depth. I mean, right now it's by default set to 4 mil. Well, we don't want that. We want it to go 80 mil depth. So, you know, 62, 64 mil thick board, so 80 mil more than punch through it. None of this other stuff you have to worry about. This in move Z, that's the final tool position. So it's set at 0.4 inch above the board. You know, in other words, 400 mil above the board. And these things I never mess with. I just do this, and I just leave it set by default, and I just adjust it in you know, in Candle for now. even though at some point I may actually do that, but see, it has control of the feed rate and stuff like that independently here. In the future, when I get more, used to this thing, I might change, start using that, but right now I don't. But we do want to put multi-depth on this, because by default, it was just a basic geometry object. It doesn't have this set by default, and instead of 31 mil, I still prefer it to be 20. Now I might be able to go into preferences, like I was showing you before, and set that. I just haven't gotten around to it yet. Again, I'm still trying to decide, because most of the time you don't want to do it multi-depth. Most of the time when you're using a geometry, just a basic geometry object, you don't want that set to anything different than what this originally was set for. But that's why this is a little tricky, because you've got to pay attention to some of these windows, which you might already have set up to defaults, but those defaults don't apply because I'm trying to route through the entire board instead of route trace. So, but at any rate, those are the main things you got to pay attention to, this and this. Okay, when you're trying to route a hole, and this is its travel Z, so it means when the bit is not routing something, it'll travel 120 mil, or about 1/8 of an inch above the board. But you can set that to something else. It's just that, on these 3018s, especially with such a thick base, I don't have a whole hell of a lot of Z depth available. And as it stands, it used to have like 400 or 500 mil, almost 500 mil and everything. It would come really close to crashing it into the top, especially when I had the expanded PVC under this and everything else. So anyway, but that's just, I try to set it as low as possible, but within reason, to where it's not going to crash into some irregularity in the board or something. So at any rate, we got that all set, so it's time to generate our CNC job. Okay, so when we do that, that brings us into this screen, which, by the way, happens to be down here. So, along with the other job we generated. Okay, and basically, that's all done. If you wanted to look at the G code, you can. It's a lot simpler with the G code, because it's just a few pathways. Actually, it's surprisingly complicated. Wait, is that the... Anyway, it's surprisingly complicated. I don't know why they do it that way. That is surprisingly complicated, because these are just, you can, oh yeah, it's circles, because we were routing around circles, I forgot. I thought it was just drilling holes, Again, borderline autistic, can't help it. Just like I can't make short videos without a hell of a lot of effort. Anyway, let me hit the save CNC code. Okay, so that saves it. ISO CNC, wherever, you could call it anything you want, but they kind of stand out, so I just kind of leave it as default. Okay, so that's got those two things taken care of. And that's fine to have done those, because I've actually got ahead of myself. This usually isn't the first step I do, but it's okay, because these apply, well, actually they don't apply universally. God damn it. Yeah, I've actually got to go delete that. That damn beeper is driving me nuts. I'm going to turn that off. Okay, anyway, that's one of the bad things about uncut videos, is that you get all the mistakes too. Okay, I fucked up. On this, let me go ahead and take that, and delete it. Because actually it should have been on the bottom side. Again, it's not a problem for the edge cuts, because it's the same no matter what. But the first thing we ought to do, given the fact this is a double-sided board, okay, and it's okay to have done our edge routes, but we should go up to tools and do the double-sided board tool. Alright, now what we're going to do is I'm going to put reference holes on this, and to do that, and you don't have to use this double-sided tool. You could have theoretically done this yourself, but it'd be a lot more convoluted. I just prefer to do it here. You got to press notice, X and Y and so forth are red down here. So notice your position. Alright, if you hit Control, press the Control button, and then left mouse click, alright, that actually records a point. So when it says alignment drill coordinates, it adds, okay? And that's the point it added if you were paying attention to the coordinate there. So, now what we want to do is we want to select box, and again, I think you can probably set these defaults up, I just haven't done it yet. Again, I haven't done that many of these double-sided boards. Alright, but we want to flip it, and again, you can flip these things, here too, manually if you wanted to. Which on single-sided boards, this is what I'll usually do. I'll use, X, I'll just hit the X key and it flips, mirrors everything. Because if you're doing a single-sided board, you start with the bottom layer, right? That's what you design, and then, but when you go to make the board, you've got to mirror it. So, but if you just press X, it just automatically flips it in a box. It's a no-brainer. You don't have to worry about any coordinates or anything. But doing this, we do because we're doing a double-sided board. So again, I put that coordinate as where one of our drill reference holes. Remember earlier in the video when I showed you that reference hole and I put a thumbtack through it? That's what we're doing right now. We're adding those holes. And again, the advantage of doing it here is that it'll treat that like a separate CNC job, and you'll see that in a minute. So you can do that separately from like drilling and stuff, because this still isn't drilling. You're doing the reference holes. But at any rate, I've already hit the, that, so let's go ahead and create Exelon object. Okay, now, let's back up. Okay, use the wrong damn whole reference thing. I'll delete this. Alright, let's see. Dang it. Okay, two-sided tool. Now, let's see. So it's referencing the stupid user drawing again. Reference the edge cuts drawing when you're doing this. Okay. Now generate the Gerber object. God damn it. Okay, what's this fucking thing doing? Hold, let me pause the video and I'm going to find out what the hell's going on. This is the reference drawing. See, it's using the wrong fucking thing. It's here, not here. That's what I'm saying. This thing could be less confusing. But, anyway, okay, so you choose the right thing there. Let me go delete that stupid object again. You notice how big those holes are? It doesn't really matter. What matters is that it's a hole. But, delete this motherfucker and okay, go back to the double-sided tool. But you can change the diameter of that because in truth, again, it's really only going to be like a 42 mil drill, like I said. So you can do that, but it's arbitrary because it doesn't. This damn program has no idea what drill you're going to actually use. Really, I mean, you can put any drill you want with like a 7-inch bit in it. It wouldn't fucking know, right? If a 7-inch bit would fit in the damn tool. But anyway, let's go ahead and get that done. And again, I kind of prefer the other holes because they stand out more, so they'd be easier for you to see that they're a hole. Let me go ahead and do it. I mean, it's nice that's real and everything, but it doesn't stand out as well as I like. So. But let me just make it like 80 mil or something so it'll be more visible to you guys. Yeah, so that'll stand out, on all these above and beyond everything else. Now, that generated, this alignment hole deal. So you got to go to that. Okay, and again, I'm going to go ahead and, I haven't gotten around to changing my defaults on this yet. Now, I could do it, but you got to go like 20 different places to do it. properties, preferences. Let's see. It's still kind of confusing where. I mean, this is relating to Gerber objects. Okay, and this I guess is the next step. And see how this is set for a cut Z of 100. I'm going to go ahead. I just got to make sure it's, because I still like leaving my drills at 100, you know, my drill depth. But that's why I've been reluctant to change this, because I'm still not exactly sure. Because see, this is epsilon, so this is probably talking about drills, so you don't want to change that here. I think this might be educational for you, because again, it's a little convoluted going through these settings. It's not going to be general. CNC job, forward, nope. Tool. So that's got that 4 mil, so that thing came from. So cutout tool. Okay, cutout tool, that's perfect. You know, because I know that's one of the things I've got to worry about. This is for the cutout tool. I'm going to go ahead and change that. Let's see where else, because that's not what we're working with right now. Well, that's a drill tool. Yeah, okay, never mind. Okay, the alignment tool, actually, you do want to leave this, because I forgot we're dealing with the damn drill bit, so it's fine. So, yeah, we don't need to worry about that. Because this is an actual drill bit, it's not a router tool. Like I said, I still leave my drill depth at 100 mil, just so it solidly goes through the board. Again, I may change that later, but I may not. And let's generate the G code for it, because again, that looked right as far as the depths and everything were concerned. Again, you can go back and check it. Materials, like I said, that had travel Z fine and everything, all this stuff's great. Show and move, all that stuff. Okay, so it went in and their alignment drills. Okay, so just say the CNC code. Again, there's really not much to mess with here. Okay, now let me go. Alright, and then, so that's got basically this done, and but we still haven't finished our two-sided PCB thing yet. So, again, I've got your, you know, our alignment holes drilled, right? But I still haven't done the mirroring yet. So, you know, things we want to mirror, and let me go ahead and go back to project and like these two things down that. The things we want to mirror are, you know, our user Gerber file. We want to mirror that. Just go ahead and hit mirror. Alright, and that put those holes. You can't see it. And then we want to do the bottom layer. We want to mirror that. Okay, so basically, oh shit. God damn it. I don't know what that fucking did, but it pisses me off it's there. It was trying to mirror drill holes. I hope it didn't do it. At any rate, that's what I'm saying. Another pain in the ass feature about this, make sure you hit box. Son of a bitch. Why they would set that up that way. Alright. So, I may have fucked it up too. I gotta go check it. Okay, the drill holes look like they're in the right place. We got our two layers here. I was wondering where the layers were disappearing to. Okay, so now the bottom layer we want to mirror, but within that bounding box. Okay, it's vanished again. layer's definitely fucking gone. So, reference Gerber, this isn't what we want to use, I know that. I don't know if that applies to this or not. You wouldn't think that it would. For fuck's sake. I don't know what the fuck is going on here. Is this shit not enabled or something? I mean, I don't fucking know what the hell. God damn it. I'm about to just scrap this and start from scratch because I don't know what the fuck this dumbass program is doing. I mean, I do not have a fucking clue. And what happened to the fucking layer? Fuck this piece of crap's doing. And just to be sure, I'm going to delete this too. Alright. Reload this motherfucker. Here, I'm going to reload these two motherfuckers. Okay, see, these holes are fucking down here now. Alright, so I'm going to have to get rid of that thing too. Yeah, these people, you know, could have thought this thing out a little better. This is, anyway. Son of a bitch. That reached the limit of my frustration. Shit can this whole video thing. This is just confusing the shit out of you guys. Let's God. Okay, let's try this fucking thing again, shall we? You know, in many ways, this isn't even worth using. Anyway, we've already generated our reference holes. I think they're still there, aren't they? Shit, I have no idea. Let me bring the excellent thing back in, too. Okay, I don't know what the fuck this thing is doing. I don't know, I'm starting to think that maybe because I'm recording this or something, it's interfering with this piece of shit. I don't know what the hell's going on. It's like this thing's gone haywire or something. There's nothing seems to be working right. What the fuck is this? I have no idea. I have no idea what this is doing.